What up, pre-calculus? Last time we talked about the basic six trigonometric definitions. Now I'm going to do 3 very basic skills. Basic skills. Anyone in their sleep blindfolded could do these. Well, maybe not blindfolded because math is visual. All right, so here we go. First basic skill after our super junior varsity 3, 4, 5 triangle is going to be the following. Let's talk about this. Given the triangle, let's see, it's a right triangle, of course. I'll say this is A, B, the right angle C has a hypotenuse of 7 and a short leg of 3. We need to find all 6 trig ratios for angle B. All right. Hey, listen, if you think you can do it, pause and then, see what's going on. But if not, follow along. Here we go. You might notice we're given 2 of the 3 sides. So the first thing we got to do is use a little Pythagorean theorem, right? 3 squared plus a squared equals 7 squared to figure out that missing little a side, right? So there's 9 plus a squared equals 49. That means a squared would equal 40. Uh-oh, we got a square root time. Here we go. A is going to be the square root of 40. We don't leave the square root of 40 there. Follow along the basic skills here, right? 40, just so you know, if you don't know your perfect square factors, is 2 times 2 times 2 times 5. You don't have to do this, but we do have to pull out perfect square factors out of 40. It's called reducing square roots, all right? Square roots looks for a pair. I see a pair of 2, so this is 2 times the square root of 10, all right? Promise, go to Desmos. I don't have it. Actually, you know what? Didn't think I was going to do this, but I've got all this technology, right? So let's do this. I'll go to Desmos on my calculator. Come on, little phone, work. All right. Anytime now. Oh, that's a fail. We'll do it later. But I promise you, 2 root 10 is the same as the square root of 40. So I'm going to call that 2 root 10. If it ever loads, I'll show it to you. All right. I don't know why it's not, but whatever. That's our first task. We got to find that missing edge, and we did. It's 2 root 10. All right. So all 6. We'll start with the sine. Sine of angle B. I look at angle B. Opposite over adjacent. Opposite over hypotenuse. That's 3 over 7. Cosine of B. Again, should be fairly easy. Adjacent over hypotenuse, so 2 root 10 over 7. Tangent of angle B. All right. Tangent of angle B is opposite over adjacent, so opposite over adjacent. So 3 over 2 root 10. Uh-oh, we've got a square root on the bottom. That means we've got to rationalize. Here we go. Times by root 10 on top and bottom, and that's going to be 3 root 10 over 20. 2 times 10. Root 10 times root 10 is 10. All right. And that's how you rationalize that. All right. So you've got your sine, your cosine, and your tangent. Tangent of B. All right. Next, we got to find the reciprocals of all these. Some of them should be fairly easy, right? Some of them might not be. Got to remember that the reciprocal of sine, we call it cosecant, right? So the cosecant should be pretty easy. Cosecant of B is just 7 over 3. As easy as can be. No rationalizing to be done, all right? The secant of B is going to be a little bit trickier because it has some radicals, and when we flip that radical on the top to the bottom, we're going to have to do a little rationalizing. All right. So here we go. The secant of B is going to be 7 over 2 root 10. But same thing has to occur. I have to multiply by root 10 over root 10. Oh, it's getting squishy here. It's going to be 7 root 10 over 20. There's the secant of b. All right? I think I figured out my Desmos thing was going on. My phone was getting crazy. In any case, that'll load soon and we'll figure out and show you that 2 root 10 is the same as the square root of 40. Oh, here it is. All right, ready? I will do, cancel that. I will do the square root of 40. And that's about 6.322. All right? 2 square root 10 is the same exact thing. It should be pretty easy, right? 10 is a little bit more than the square root of 9. The square root of 9 is 3. Just thinking about numeracy in your head. So 3.1, maybe 3.2. I'm not quite sure, but if you double that, and we're going to get 6 point something. Maybe square root of 10 is like 3.15, it looks like. Approximately. If we double it, we get 6.32. All right, so it is the same thing. Anyways, we've got 1, 2, 3, 4, 5 of those. Now we just have to find the cotangent of b. All right. Now here's the thing. I could reciprocate my final answer, or I could go over to my tangent before it got rationalized, right? Because if I just take my tangent, this and this are the same thing. So I think it'd be easier to flip this around, right? So it's just 2 root 10 over 3. Super easy. All right. Hey, listen, if any of that was hard, rewind, go back to the beginning, pause it, see if you can get all these, and you got the answers here. All right. Our next basic skill, here we go. Our next basic skill is going to be given theta is negative 5 pi over 6. Oh yeah, radians, here we go. Find all 6 trig ratios for theta. All right, so let's give a nice, neat unit circle. There we go. Negative 5 pi over 6 is in the negative direction. Here's the first pi over 6. There's the second. There's the third. There's the fourth. There's the fifth pi over 6, so negative 5 pi over 6, often known as 7 pi over 6 in the positive direction, right? So it's a 30-degree angle in the third quadrant. In the third quadrant is nice and key, all right? While this is angle theta ends right there, we're going to use the reference angle right here, closest to the x-axis, all right? And here's the thing, you should know all of these things, right? This little leg right there, that's negative 1/2. Boop. This longer leg here is a negative root 3 over 2 and with a hypotenuse of 1. All right, so some of these things should be pretty easy. Sine of theta, nice and easy. Sine of theta is that negative 1/2. Cosine of theta will be negative root 3 over 2. Tangent, all right, tangent is a positive value. And if you do the math, it'll be square root 3 over 3, all right? Doing the math on tangent, I'm not going to do it for you in this video, but it's opposite divided by adjacent, all right? Or sine divided by cosine, all right? Flip that one over, multiply, got to rationalize, you end up with a positive because you got a negative divided by a negative root 3 over 3. All right, pause the video and do that if you need practice. All right, in any case, all 6, I've got 3 of them. I need all 6 trig ratios, all right? So the reciprocal of sine is cosecant theta, and that will be negative 2 or negative 2 over 1. I'm just not going to be, I'm going to be super cool and not do the over 1. The secant, we're going to have to do a little bit of rationalizing here. It will be negative 2 over root 3. All right, let's scoot this over just a tiny bit. So that ends up to be negative 2 root 3 over 3. So there's the secant. Tangent, or the cotangent, I should say, cotangent of that angle. Again, we're going to have to rationalize. In its inception, it'll be 3 over root 3, or the reciprocal of tangent. All right, do a little rationalizing. And you will see that it is 3 root 3 over 3. The 3's cancel out, and so you're left with root 3. All right, so there is the cotangent. All right. Cooper, get the door, please. Sorry. This COVID-19 video fails. All right. Last deal here. Cooper, get the door. Cooper! Thank you. All right, last video or last problem on the deal. Oh, it's gonna be one of your faves. All right, I've been kind of leading up to this one. All right, so here we go. Here it is. Suppose that we have an angle and it lies in the third quadrant. All right, so again, we're sticking in the third quadrant. And I'm telling you that the secant of the angle is negative 3 root 2 over 2. All right?
I'll be right back.
So there's the secant. Find all 6 trig ratios for theta. Hey, we were given 1. We just got to find 5 more. All right? Is theta closer to the x or y axis? Y. All right, here we go. Part A. This is the one you guys hated. It used to be all 3, but now we're doing all 6. All right, so again, visual. All right, I'm going to be in the third quadrant. There's pi. There's 3 pi over 2. All right, I'm going to just draw some angle in there. It might be the right, it might be the correct angle. I might have drawn it in the correct place. I might not have, but it's just for labeling purposes. Okay. The angle that we're dealing with is this angle right here. There's angle theta, but we're going to be using the reference angle right there. Okay. All right, so here's the deal. We are given secant theta to be negative 3 root 2 over 2. Here's my suggestion. When you're given that, go ahead and find the reciprocal of secant. Right? You don't really need to do any visualness, right? But this is just knowing our reciprocals. Secant is the reciprocal of cosine. So automatically we know that cosine is going to equal 2 over negative 3 root 2. Got to rationalize. I know you guys love this. Get used to it. 2 root 2 over, let's see, this would be 3 times 2, which would be 6. And it's negative. This will reduce, the 2 and the 6 reduce to negative root 2 over 3. So there, in all of my deals, there's my cosine ratio. All right. This is really going to be where the bread and butter is. When I know my cosine, that's what I'm comfortable with. I've got my adjacent, I've got my hypotenuse, and now I can start labeling. I could have done it with this too, all right? This seems to be in easier terms though, all right? Either one could have worked out, okay? So now we'll go and label my triangle, all right? The adjacent is going to be negative root 2. The hypotenuse is going to be 3, all right? Little Pythagorean theorem later. Let's see, I've got negative root 2 squared plus my opposite, we'll call it y squared, something I don't know, equals 3 squared. This is going to be 2 plus y squared equals 9. So y squared will equal 7. That means y will equal the square root of 7, positive or negative. And in our case, it will be the negative, because we're in the third quadrant. Okay. So now that I've got my third one, I'm like home free. All right. Now I can start to think about the 4 other trig ratios. I've got the secant and the cosine. Let's go ahead and find the sine of that angle. The sine of that angle should be fairly easy. Negative root 7 over 3. And then the cosecant will be the reciprocal of that, which would be negative 3 over root 7, but you got to do a little bit of rationalizing, so that'll be negative 3 root 7 over 7. So there's the cosecant. All right, so I got my secant, my cosine, my cosecant, my sine. All right, I can do my tangent. Tangent should be fairly easy. That's opposite over adjacent, right? So negative root 7 over negative root 2. Oops, not double root, negative root 2. All right, and that's just going to be root 7 times root 2 over root 2 times root 2. Got to multiply by root 2 and root 2 on top and bottom. This will lead to a root 14 over 2. There's my tangent. All right. Cotangent is the reciprocal of that, right? So you could flip that over, or you could flip this over and rationalize. I'm going to flip my final answer over lots of different ways, but you should end up in the same place as we go here. So this will be 2 root 14 over 14. 2 and 14 reduce, so the cotangent is going to be root 14 over 7. All right, so I got 1, 2, 3, 4, 5, 6 values for all my trig ratios. All right, that's part A. Done. All right, part B, is theta closer to the x or y axis, and why? All right, well, let's think here. This question always makes you look at these two sides, the tangent ratio, opposite over adjacent or adjacent over opposite, the tangent-cotangent relationship, right? And it truly makes you think of ratio. Which one of these is bigger than the other? Well, they're both square roots. 7's bigger than 2, so it looks like 7. Square root of 7 is bigger than square root of 2, so I didn't quite draw this correctly, all right? Square root of 7 should be a little bit longer than the square root of 2, so maybe I should have drawn it something like this, so it's a little bit steeper. All right. If that y leg is longer, it's going to be closer to the y-axis, right? So part B, theta is closer to the y-axis. Here's the reason. Because square root 7 is greater than square root 2. Or I could say that the sine, the absolute value of the sine, is greater than the absolute value of the cosine. All right? And if the sine is greater, you're going to be closer to that y-axis, which represents what the sine is. All right, signing out. Those are our 3 basics. That was a big one. Sorry, guys.